Hi, today I would like to do a C# max binary heap implementation. So let's get started. Basically, I've defined a node and it's going to have some data, which is an integer, and it has a left and a right. And the only other addition I've done over the traditional implementation is to add a parent so that we can easily create a max binary heap. So one of the properties of a heap is that the root node or the node which is the parent has a higher value than the children. So in this case, for example, 67 is greater than both 47 and 55. And here we have another node called 47, which is greater than 45. So that is one of the main properties of a binary heap. So if you look at it, to do this implementation, I have essentially created a class called max binary heap, and there's a constructor where you just give it the node and it becomes the root node. And I've also added a variable to keep track of my insert position for optimal operation. So insert position initially when you insert something is just going to be the node. Then I have provided a method called insert, and you basically give it a node, and it's pretty straightforward when you do the insertion. So the way to do the insertion on a tree here to conceptually is that if there is nothing to the left of the insert point, in this case the insert point is going to be 47 for this tree. So if the insert point 47 doesn't have anything to the if it has something to the or nothing to the left, you can just insert it over there. Otherwise you insert it to the right. So that's what this is doing. And after you do an insertion, you have to do something called a balance heap. And in the right case was also the same thing, but in addition to balancing the heap, you have to adjust the insert position, where the insert position is going to be. So to conceptually think about an insertion into this tree, I would recommend taking a look at this Wikipedia article, which is on binary heaps, and it is a good explanation of an insertion. So this is, let's say, a heap, and we wanted to insert some element here called 15. So you'll find the insert position by doing essentially a breadth first search. So and find the very left position. In this case, it's going to be X. So you insert 15 over there. But then you look at the parent, and that's why I have the parent node. So what you do is, if parent is less than that, you will have to swap it. So 8 would go down and you'll have 15. Then you do the same thing over here. You swap it, 15 will go to the top and 11 will stay here. So that's how you get to the adjusting of the position is basically that. And insert is going to be that. That's called the balance heap. That's what I've talked about. And then the adjust the insert position is essentially going to be a breadth first search. And so it's just pretty standard. I have done another video on breadth first search, so you can take a look at that. But basically the main point is to be able to set the insert position, we need to find the very most left node which does not have which is null, and that's what it does, and then it just breaks from it. And that's what insert position is doing. And this is a breadth first traversal standard that I've done before, and I'll kind of show you, is to basically print out. So let me have inserted 3 breakpoints here to kind of show you what the tree looks like. And let me just start this program and I'll show you how it goes. Okay, so I have the breakpoint at the first point, and this is what the tree initially looks like. And you can see if you do a depth first traversal, it's going to print 67, 47, 55, and then 45. So that's what it did. And after I have done that much in the tree, I'm going to insert 3 more nodes with values 60, 81, and 51, and again kind of print this. So I've done insert of 3 nodes, and I have printed this information, and it's going to have this tree. And I made a diagram for you so it will be a little bit easier to see. So it's going to be essentially 81, 60, 67, 45, 47, 55, 51. And the last thing I have done after this is to insert another node for 95. So you can see the max node is always going to be at the top in this kind of configuration, and it gets printed first. So if you see it is going to print 95 first. So if you want to look at it, that's what it is going to be: 95, 81, 67, and that's pretty much what it is. So if you just want to understand, let me just show you how the last insertion is going to work. Last insertion is going to find the leftmost tree which has a null. So it's going to insert 95 here, right? So, but 95 and 45 are different, so it's going to swap them. So 45 will become this way and 90 will come. Then we look at 60 and 90, it will swap them. So 90 will be here, 60 will be there, and then 95 and 81 would be swapped. And that's what you basically end up seeing here. So that's how the max heap structure works, and it's much easier to understand. If you look at the Wikipedia, they usually try to use an array implementation. It's much harder to grasp. There is a second portion to this which is called extract. Typically what extract means is you take out the max node out of the tree and rebalance the tree, but I haven't done that, and if you want to do that, feel free to do that on your own. Thank you for watching this short screencast. If you want to learn more, you can essentially go to my website Gaur Associates and search for these and many other videos. So let's say if I wanted to search for algorithms, and let's say I just wanted to search for Princeton KMP algorithm, I can find that over here. And thank you for watching this short screencast, and you have a great day.